Bun găsit la emisiunea Știință și Cunoaștere. Clima și mediul se modifică în permanență. Specialiștii se străduiesc să elaboreze diverse scenarii. Unele ar indica un tipar de încălzire continuă. Altele ne-ar spune că, de fapt, în ultimii 30 de ani, temperatura medie anuală a rămas neschimbată. Alte scenarii ne indică faptul că variabilitatea climatică a fost întotdeauna determinată de oscilații între perioade mai calde și perioade mai reci. În data de 24 februarie 2015 am înregistrat primul interviu cu climatologul Tim Ball din Canada. Am realizat atunci o serie de 7 episoade despre înțelegerea climei și a mediului cu promisiunea de a continua în anul următor. În contextul unei prime coincidențe neobișnuite s-a nimerit să înregistrăm acest nou interviu în data de tot 24 martie și exact la aceeași oră, ora 19 aici la Cluj, dar un an și o lună mai târziu. Întrebările pentru domnul profesor au fost pregătite în 22 martie 2016. O altă coincidență neobișnuită se referă la faptul că în partea a doua a primului interviu de anul trecut, profesorul Tim Ball îmi spunea că unul dintre cei mai importanți factori care ar putea întârzia manifestarea unui tipar de răcire continentală sau globală ar fi un El Nino de mare intensitate. Ei bine, la doar câteva săptămâni de la finalizarea interviului din 2015, specialiștii de la Institutul Național de Studiere a Oceanelor și Atmosferei, NOAA, au anunțat apariția unui sistem climatic de mare intensitate în Oceanul Pacific. O altă coincidență este aceea că am înregistrat interviul în martie 2016, dar difuzarea în premieră a fost prevăzută pentru luna iulie 2016, de unde rezultă că ar putea părea firesc să ne referim la o primăvară lungă și rece la timpul viitor, însă noi am vorbit în cadrul interviului despre o primăvară care tocmai s-ar fi încheiat, pentru că am estimat comportamentul climatic înainte ca acesta să se producă. Și am menționat acest lucru pe imprimare, dar în realitate, la vremea imprimării interviului pe Skype, primăvara din 2016 era abia la început. Fenomenul s-a produs, dar el a fost prognozat înainte de a se produce. Aceasta reprezintă o dovadă a faptului că invitatul emisiunii are cunoștințe științifice valoroase. Este pentru prima dată când suntem martorii unui asemenea eveniment. Partea introductivă a celor două emisiuni a fost scrisă după împlinirea evenimentelor spre finele lunii mai 2016, care la rândul ei a fost foarte rece în fiecare dimineață. Peste câteva momente, Tim Ball ne va explica ce este și ce efecte a avut acest sistem climatic, după care ne va prezenta un scenariu al evoluției climei în zona Europei și a României, pe termen scurt, respectiv pe termen lung, iar spre finalul primei părți, Tim Ball ne va explica în ce mod oceanele influențează clima, care este rolul Gulf Stream-ului și altele. Dear Professor Tim Ball, welcome back to our program Science and Knowledge here on TVR Cluj, Romania for a new mini-series of interviews regarding climate changes.
Well, thank you, and I appreciate the opportunity to try and help people understand what's going on with the weather and climate, because there's so much misuse of the data for political agendas these days that getting to the truth is so critical.
Last year, we presented 7 episodes about global cooling, understanding climate changes, extreme phenomena, earthquake. We also discussed myths and many more. Now I came back with this new interview request because something amazing happened in the meantime. Let me explain first. We recorded the first 2 episodes in March 2015. We began talking about global cooling and a lot of things you presented in your book entitled The Deliberate Adoption of Climate Science. Then, on episode 2, in the second half, I asked a question if there might be other natural forces which could prevent or delay the global cooling. This is your answer, which our viewers may verify exactly at the time code 41 minutes and 19 seconds.
If a cooling or the cooling trend that is now set in will continue, it could be delayed by 1 or 2 years by some local effect, the El Nino, for example. If you have a particularly strong El Nino, that could modify it slightly for 1 year. But in the longer term, no, there's nothing you can do to prevent the trend.
Quote ends at exactly 41 minutes and 46 seconds. And I remember that at that time, it was barely supposing that there were some indications that we may or may not have an El Nino without any knowledge about how strong would that be, and it proved to be relatively strong, although some opinions are not all convergent. But your scientific comments about cause and effect were accurate. By the way, this year we had a moderate winter in Romania and a little colder spring.
Well, thank you. And of course, you can define science in one word, prediction. If you cannot predict, your science is wrong. And of course, that's one of the critical things with weather forecasting and climate forecasting, that all of the predictions that the Intergovernmental Panel on Climate Change, the UN agency, have made about the global temperature trend have been wrong. But instead of going back and re-examining their science, the basis for their forecast, they simply changed the terminology. So what was global warming suddenly became climate change. And so I'm very pleased that you picked up on my comments about El Nino, because some of the major mechanisms of weather and climate are well known. It's just that in the official climate science, they leave out major mechanisms. And we've talked about some of that, some of the mechanisms of the sun. I'll mention another one here today, which has had an influence in Romania, and that is the effects of the monsoon, bringing in very warm weather in and rainfall, heavy rainfalls, and so on. So it's these transfers of heat mechanisms that are relatively well understood, but because they don't give the forecast that the government want, because they're using weather for a political agenda, then they ignore them. And so this is a very important point for the listeners, that if your science doesn't predict, it isn't science. It's what they call pseudoscience, that is a false science. And of course, that's what we're trying to do on these programs, or at least what I'm trying to do, and I know you're interested in, is getting people to say, well, what do we know? What don't we know? And how close to the truth can we come as citizens to understand what's going on?
Please make a comment about how all this happened, and how was the winter in other countries before and after this El Nino?
Well, the El Nino is actually really only affects the subtropical latitudes. It's an ocean current that occurs in the tropics, and it really doesn't affect the rest of the world. It adds some heat into the atmosphere, but it became, and this is one of the things that's happening, is that as people became aware of the weather and the climate, because it was being used for a political agenda, then natural events like El Nino suddenly the public became aware of them. And the El Nino is nothing new. It's been going on for thousands of years, but it really only affects the tropics. And it became big news back in 1983, when instead of affecting the northern South America and the Central America, it shifted north to affect Southern California. And of course, as you know, and your listeners know, we live in a world where if something affects California, that affects the whole world. And this is part of the bias of the news about science. So, for example, they have an earthquake in California, and there's a week of television and stories about it, and maybe 2 or 3 people die, which is regrettable. But 3,000 people can die in an earthquake in China, and it hardly makes the news at all. So there's a very strong bias to what's being reported in the news. And this idea that El Nino is somehow something new that is part of what is being created by human activity, it is simply false. we have very, very good records of El Nino, for example, starting around 1500 AD, when the Spanish started sailing into the Pacific Ocean and became aware of the El Nino currents because it affected their sailing and everything else. And they discovered that the Inca, the people that live in Western South America, were very knowledgeable about the El Nino and its effects. For example, every spring, the leaders would go into the Andes Mountains and look at a set of stars called the Pleiades and determined whether the rainfall would come early or late, depending upon how the stars looked. So if the stars were sort of twinkling and not clear, they knew that there was an El Nino event going on, and therefore they were going to get one set of rain patterns. But if the stars were very clear, then they knew there was no El Nino and they'd get a different rain pattern. And they planted their potatoes based upon that forecast. Now, they didn't know it was related to El Nino and how the mechanisms worked, but they were seeing the effects and knew through watching it for centuries to be able to make a forecast. Part of the problem we have that we're talking about here is that the modern weather people think that only their record is accurate and usable. So they only look at about 100 years of record. And in 100 years of weather record, you can't possibly incorporate all of the variability of weather that goes on over centuries. So we're seeing weather patterns now that we haven't seen for about 1,000 years. And unless you know that and build that into your understanding of El Nino and all of these other things, then your chances of forecasting the weather accurately are very, very bad. So El Nino is not a new event. It's something that the public became aware of, as I said, back in the 1980s. And then in 1998, we had a very strong El Nino, which put enough heat into the atmosphere to cause global temperatures to go up. But the El Nino itself doesn't affect the weather patterns in Romania, for example. But what's happening is that El Nino is caused by a reversal of winds in the tropical region or subtropical region. At the same time that what's causing that, which is effects of the sun, and we'll talk about that a bit later, the jet stream is also being affected by external forces from the sun. And so they look at it, they say, oh, well, El Nino is occurring and the weather up in Romania is changing. Therefore, El Nino is causing the Romania weather to change. It isn't. The changes in the Romanian weather are due to changes in the jet stream, which is a completely different global wind pattern. So it's like saying, okay, I'm looking at my car, and I notice that every time the front bumper moves, the back bumper moves. So I conclude that the front bumper is causing the back bumper to move, right? It isn't at all. It's because the whole car is moving, right? And so this is how bad the science is of what they're doing with El Nino. And so you're seeing a global change of weather patterns that's affecting the tropical winds and the mid-latitude winds, and also, by the way, the polar winds, because you're seeing this year a decline in the ice, Arctic ice. They're saying it's a low level of Arctic ice. Well, that's because of the wind patterns have changed in the Arctic. So the ice is being blown around, and also warm water is being blown into the Arctic region, which affects the ice cover. The story they want to tell the public is, oh, no, it's all due to human-caused global warming. It isn't. It's due to natural changes in the atmosphere and its circulation. But because the public don't understand, then these lies can be put about oh, it's humans are causing El Nino and they're causing the ice to melt and so on. And so we're in a very interesting weather pattern. And what it's doing and maybe I'll elaborate on this. Well, we go to your next question.
Yes, because I'd like to help in educating the public. Climatology is an extremely large domain of study, and we do not have time to explain it, all of it. So we have to choose the most urgent and interesting matter, and since we never presented the El Nino La Nina phenomena and other topics that we are going to discuss later, please explain in full details what is an El Nino La Nina phase and how much this influenced the climate in the past 100 years.
Okay, the El Nino La Nina is a reversal of the ocean currents in the Pacific Ocean. Now, you get similar reversals of currents in the Atlantic and the Indian Ocean, but because those oceans are much smaller, you don't see the effect quite as much. The Pacific, of course, being a massive ocean, everything is amplified. And so it's sort of like if you got a flea on a bear, it doesn't affect how the bear moves around. Well, that's the situation we've got. The other point, just before we talk about El Nino La Nina, is that climatology, and we did talk about this in previous programs, just to bring it forward again, is a generalist discipline. So if you think of climatology like a giant jigsaw puzzle, and people do jigsaw puzzles, I assume, in Romania. You know what a jigsaw puzzle is? Pieces that you put together to make up a picture?
Yes.
Well, okay, with climatology, we haven't even, the way you do a puzzle is you find the corner pieces of the puzzle. Well, we haven't even got the corner pieces of the climate puzzle. The corner pieces are of course, what's going on in the oceans, what's going on the land, what's going on in the atmosphere, and what's going on in space. We haven't even got those corner pieces. And then we haven't even got all of the edge pieces, because when you do a puzzle, you find the corner pieces first, then you get the edge pieces, and then you sort out the pieces for the inside of the puzzle according to the color. Well, what we've got today, because of specialization, which we've also talked about, you get one scientist who's got one piece of the puzzle, and of course is looking for research funding and saying, oh, my piece of the puzzle is the most important, fund me and I'll solve all your problems. But when you start to put that piece in the puzzle, it doesn't fit. So one of the things, this is what El Nino has done, that suddenly somebody's come along and said, oh, El Nino is the key to everything. And, oh, look at the weather patterns it's affecting this year. And of course, they made forecasts and they were wrong. The forecast was wrong. But El Nino La Nina, as I said, has been known about for, you can see it in the record. We've got historic records going back to 1500. What happens is that in the tropics, the winds blow from the east to the west. Now in Romania, you've got the opposite, that the general wind patterns are from west to east. When you're looking at the weather that you're expecting in Romania, you look to the countries to the west of you because that's where the weather's going to come from, right? And so you very rarely get east winds in Romania. Most of it's coming from the west or the north. But in the tropics, it's the other way around. On average, the wind blows from the east to the west. And that's called the tropical easterlies. But about every 2 to 7 years, those winds stop blowing and start blowing in the opposite direction. All right? That is a reversal of the wind. And the wind at the surface, as the wind blows over the surface of the ocean, it drags the ocean along, and that's what creates the ocean currents. Okay, so when you've got the wind blowing from the east to the west, the ocean currents are moving the water from South America to Asia. Okay, and that's La Nina. And so that what you get then is, as the water is moved away from South America, the cold water comes up from below to replace it. You get cold water in the American side of the Pacific and warm water on the Asian side. Now, the winds reverse themselves. And this is a critical point. Nobody has explained why the winds reverse themselves. And so it's like, it's the old chicken and egg. Which comes first, which causes which? Well, the tropical winds reverse themselves. So now you've got the wind blowing from Asia towards South America, and the ocean current reverses itself. So now warm water piles up off the coast of South America, and you get cold water coming up off the coast of Asia, and you get a complete reversal of the wind patterns. And later on, we talk about this in the figure 3 in that article that I sent you.
Yes.
Okay,
I'll now ask you to make a new hypothesis, knowing the fact that this long El Nino is now approaching its closure. Please tell us, what is the most probable temperature and rain change that we might expect on short term, the next years to come, and on longer term, the next decade?
Well, the difficulty with that question is that if I only talk about El Nino, then I can talk about the pattern that will occur in the tropics and the subtropics. But when you ask that question about the weather patterns for, well, we'll use Romania or Canada as an example, because we're essentially the same latitude, then we have to look at what the jet stream is doing, because that's really what dictates your weather there. Now, when my theory, and this is just a theory because, as I said, nobody has ever actually done research on this, what causes that wind to reverse that creates La Nina and El Nino? And I think that what happens is that the Earth's atmosphere is under pressure from the solar wind. That is, the sun is putting out particles, which we call the solar wind. It compresses the atmosphere of the Earth. So the magnetosphere, that is the magnetic field of the Earth, is compressed on the sun side. So the sun wind coming in and compressing, and it streams out millions of kilometers into space on the downwind side. I think that also causes the atmosphere itself to be compressed, right? So when you've got a strong wind, of course, the atmosphere is compressed more than when the solar wind is weaker. So the atmosphere is expanding and contracting like this, based upon the strength of the solar wind. Just, when you have a bellows, you know what a bellows is? That, when you're trying to create wind to make a fire go?
Yeah.
Where, and so you push, and you go both ways. So when you're pushing this way or going this way, you're still getting, you get the wind. It's like with the toothpaste tube. You can squeeze the tube and the toothpaste will come out. If you squeeze the other side, the toothpaste will go back in.
Yes.
Right? So it creates different pressures, creates different winds. I think that changing pressure of the solar wind causes the atmosphere to expand and contract. That causes the subtropical winds to reverse, because they're very weak. They are not strong winds at all. They're quite weak winds. But the jet stream is 4 and 5 times stronger, so that the pressure reversal is not enough to cause the wind to reverse, but it does cause it to go into different pattern of wind. So instead of a jet stream that's fairly low amplitude waves like this, which gives you one set of weather patterns in the middle latitudes in Romania, the jet stream starts going more north-south, changing the whole pattern of weather. And I need to introduce another idea here, Christian, that's very important as this. Statistics, which is applied mathematics, only came into our world or societies in about the 1920s or 1930s. It is, of course, the idea of probability. That is, what are the chances of something occurring? And statistics has 3 parts. There's the average, okay, which is a statistic. And to help your watchers understand this, a farmer phoned me and he said, "What are the chances of average weather this summer?" And I said, "Virtually zero." And he said, what do you mean? I said, because the average is a statistic. It's made up of the difference between the maximum and the minimum, and you get the average. Okay, so when we talk about, say, well, what's the climate of Bucharest? Well, you get the average climate of Bucharest. That is, what has the average temperature been over the last 30 years? All right, now that's one thing. The second thing in statistics is a trend. So you've got the average from year to year, and how is that trending? Is the average going up or is the average going down? And in the 1970s, we started to look at trends, because in climate, that is, particularly. Now, you can apply this, by the way, to society in general, because when you look at how we talk about groups of people, are they average people? Are they above average, below average? Is your weight above average or below average? Well, how do they determine what the average is? So we have the average weather, and then we have the trend of the weather. Well, in the 70s, the global temperature was going down. And so they said, oh, well, the global temperature is going down. It's going to keep on going down. And people like me were saying, no. There are cycles to the weather, okay? And so, of course, starting around 1980, the global temperature started to go up again. It's going to keep warming forever. And all of the scares of that. Well, what we're talking about now is the weather pattern temperature is reversing itself, and we're starting to a cooling trend. So you had average, and you have trend. But what's really important from year to year is the variability of the weather. No farmer ever uses this year's weather as the basis for his prediction for his crop planting and what his expectations are for next year, because weather varies from day to day and from year to year a great deal. So you've got an average, but the average is made up of the variation. Well, the variation changes all the time, but you can have this wide of a maximum and minimum and this average. You can have this maximum and minimum and the same average.
Yes.
Okay, so what's happening now is the weather, because of the changes in El Nino and because of the changes in the jet stream, the weather is becoming more variable than we've seen for a considerable period of time. And this is what's happening. This is why your comment about Romania having a mild winter now with a cool spring is because the jet stream waves, which normally move through on about a 4 to 6 week basis. So if you've got whatever weather you're getting today, you can say, well, all right, in 5 weeks, the weather will be the opposite. Well, now, because the jet stream waves are doing this, they're not moving from west to east as fast as we expect. And so you're getting weather that lasts for 8 to 10 weeks at a time. That's why your winter was mild for such a long period of time, because the jet stream waves were not moving as they expected them to. But once it started to shift, then you get into a cold spring, and that you will see that's the pattern. So the statistics applied to weather, it really is very difficult, because the weather patterns are changing over thousands of years. There are mechanisms. Well, we talk about El Nino, it's 2 to 7 years, but then there are longer cycles in that pattern of El Nino changes. And the same is true of the sunspots we talked about. You've got an 11-year cycle, you've got a 22-year, you've got a 300-year cycle, and there's a 1,200-year cycle. Well, if you're only dealing with the modern official record of 100 years of temperature record, which is what you got for most official records, that doesn't represent anything. And if you take 100 years of weather out of the 4.5 billion years of the Earth's history, I mean, what sample size is that? It's just ridiculous. But that's what's happening. So what's going on right now is that we're into weather patterns that we haven't seen for about 1,000 years. We've been in a warm period, and people are going to really appreciate that. I mean, I wish it would get warmer. I think the world is far better off. If you think warming's a threat, global cooling is a much greater threat.
Yes, but based on the past historical events and the present signs, what kind of climate we might expect in Romania on short term, the next years to come, and then on longer term, the next decade?
Okay, in the short term, those jet stream wave patterns will continue to be extreme, so the weather will continue to be variable. And people get uncomfortable when a certain weather pattern lasts too long, because that's when you can get the drought or the heat waves or the very cold spells. That pattern of increased variability of the weather will continue, and it's occurring because the Earth is cooling down. And the dome of cold air that sits over the polar regions, that is expanding. And so what you're going to see is continued variability, extreme variability of the weather, longer spells of weather that you've been experiencing, but also when it's warm, it'll be very warm, and when it's cold, it'll be very, very cold. And so you're going to see an increase in extremes of weather conditions. Now, the other thing that happens with that is that most of the rainfall that occurs is only basically two types of rainfall. One is where you get clouds move in, the cloud gets lower, it starts to rain, and the wind starts to blow, and it rains for, a day or 2 days of steady rain. And normally in Romania, that would be when you get an east wind. Okay, that's called frontal rainfall. It's associated with that jet stream and the polar front that's associated with it. You're going to see more of that, but then in the summer months, you get a different kind of rain. Because what happens in the summer, and I know you could make this as a forecast in Romania through the whole summer, clear in the morning, clouding over towards noon, chance of showers and thunder showers in the evening, right? And the reason for that is that as the sun comes up in the summer, the heat heats the ground, the moisture is evaporated, and as the air rises in bubbles with that moisture in it, clouds form, what they call cumulus or heap clouds. And you can see, by the way, the level at which the condensation begins, because the base of the clouds are quite flat. And then they form into these clouds. Some of those will develop into showers and thunder showers later in the day. That's a very predictable pattern of weather in the summer months. So you're going to see more of the frontal weather and the rain, and you're seeing it already with the heavy rainfalls that they're seeing in Britain, Germany with heavy rainfalls. You've probably already had some heavy rainfalls. Not yet. But you've had the dry period. You see, that's the other side of it. Oh, yeah. So what you'll see is longer dry periods, but also longer and heavier wet periods. Now, we had a similar pattern of weather historically around 800 to 900 AD, as the world was cool at that time and was warming up to the medieval warm period. Well, this is the same pattern that's occurring. And so what you're going to see, as I said, is you're going to see increased variability of the weather, longer periods of weather, and a greater intensity of temperature, hot and cold, and wet and dry, because of what's happening with the jet stream waves as the Earth is cooling down.
And long term.
Okay, the cooling, that's that dome of cold air expands, and the cooling continues. Global temperatures will continue to drop. You'll see colder winters in Romania and across the northern hemisphere. The temperatures will become generally much colder and overall, and that will last based on the solar cycle probably until it will reach a minimum around 2040. So the global temperature will continue to decline to then. Then the sunspot cycle will reverse and will go into a warming trend. But overall, so we've got a short-term trend of warming and cooling, but the long-term trend is much longer cooling. Because right now, we're on a global scale and a long-term scale, we're in an interglacial. Okay, so 20,000 years ago, Romania and Western Europe and Siberia was under huge ice sheets just 20,000 years ago. We came out of that in the last 20,000 years. And just to give you an idea how quickly and rapidly it changes, sea level rose about 150 meters in a period of about 5,000 years. So 6,000 years ago, England was connected to Europe by land. The North Sea didn't exist. That's just 6,000 years ago. And that was because all of the ice that formed those ice sheets had been taken out of the oceans and the ocean levels lowered. As those ice sheets melted, the water goes back in the oceans and the ocean levels rise. So the longer term trend is that we're in that interglacial heading back to another ice age. But that the pattern of that really won't be, we won't hit the full ice age for about 16,000 years. So that's good news.
So we have some more time until then. But regarding this moderate cooling, which you told us that is about to show a minimum in the years 2030, 2040, but when do you think it will begin to be worse for us here in Romania? When do you think the agriculture in Romania will be under threat?
I think that...
But 2020, 2025, 2030, when it will be?
Again, that's a sort of a difficult question. It's not difficult in the sense, but it's a more complex answer, because temperature can change quite considerably before it affects plants and plant growth. And of course, one of the great mistakes they've been making is that they talk about tree rings being a measure of temperature. They're not. They're a measure of precipitation. And one of the difficulties we've got is our measurement of global temperature is extremely limited. We've only got weather stations that cover at most 25% of the world's surface. So, the temperature is not as big a factor for plant growth as precipitation is. So what's going to affect, and you're already seeing it with these longer periods of dry spells, those become more problematic before the temperature becomes a problem. Now, one of the things that I like to tease the environmentalists about is that we've got we've created a bigger problem for agriculture because governments have bought the global warming argument. So they're preparing for warming, when in fact, the temperature is getting cooler. Okay, so the farmers and agriculture is going to have to adjust to cooling when the government are telling them prepare for warming. Ironically, one of the better solutions, because when you look at history, for example, the Great Drought in America in 1930s, the Dust Bowl and all that, 1988-89, the drought was worse than 1936. But because of modern technology and better understanding of soil conservation, better seeds, they were able to cope with the drought much better. Therefore, the public were not as aware of the fact that it was worse than the 1930s. Now, if we get a cooling trend instead of warming, the ability to produce seeds to cope with the different weather patterns has changed because of genetic modification. Now, of course, nobody wants to talk about genetic modification. Oh, it's terrible, it's causing Frankenfoods and all of these sorts of things. But here's the difference. People have always had plant breeding. That is, we cross plants to create a different plant with different characteristics. We've been doing that for 10,000 years. But what we were doing was taking whole clumps of genes and transferring them to a new plant, right? So it was like doing surgery with a chainsaw, okay? With genetic modification, we can now take a single gene and modify the plant. And not only that, but we can put in a gene that will turn on and turn off that gene. We can control when it will operate. The difference is that under present rules and regulations globally, it takes about 18 years from the time you start plant breeding to produce a new species, a minimum of 18 years. With genetic modification, you can produce a new plant species in 18 months. So the ability to adapt, and if the temperature gets colder, the ability to produce a seed that would handle the new colder conditions or the new drier conditions, the technology is there to deal with that. And so, yes, the weather patterns are going to become problematic for agriculture, but our abilities to deal with it have, because of science, have improved dramatically. And of course, I say that the politicians are making it worse because they're preparing people for warming when, in fact, cooling is the greatest threat. Now, what's interesting, Kristen, is that they could have, if the government had planned for cooling, the adaptation to warming is much easier. Because if you look at Romania, you simply adapt the agriculture of the countries that are south of you. Because as the world warms up, you start to get their weather patterns, right?
Yeah.
Right? But who's farming north of you? Not much, right? Northern Russia, there's no farming going on. So if you get cooler, you're basically out of business. It's like in Canada, for example, if the world cools by 1 degree Celsius, over half of Canada goes out of agricultural production because the plants and the crops that we're growing are right at the northern limits of them. So that's the same for Romania, that you're really at the northern limits of agriculture as we practice it today. And so if you prepare for cooling, the adaptation to warming, if you're wrong, the adaptation to warming is easy. But if you plan for warming and it cools, you're in a lot of trouble. That's the situation that our politicians have created for us because they have not understood the climate and they have been sold really a lie by the Intergovernmental Panel on Climate Change. So from an agricultural perspective, the thing that the farmers have to watch for is not so much whether it's going to get cooler. They might get earlier frost length of the frost-free season will get shorter, and they can adapt by growing crops that are like you go from growing wheat to oats and barley and northern crops like that. But the bigger problem is increasing drought, prolonged droughts. And droughts have the greatest effect of any of the weather or climate conditions on plants and animals and humans. And in fact, in the year 2000, when 100 climate experts were said, what were the worst climate conditions in the 20th century? Of the top 20, 11 of them that they listed were droughts. The next 5 they listed were floods. So out of 20, you've got 16 of the worst weather events were either droughts or floods. That is why the focus on temperature that's going on in today's world is really not important. What's important is what is the precipitation pattern going to do? Now, it's important in terms of as I say, plant production, crop production, and so on. The temperature is only a factor in terms of your energy costs. So if you get colder, your heating bills are going to go up. Your cost of running your diesel engines is going to increase. So temperature isn't what we should be focusing on. We should be focusing on precipitation.
My next question is related with the land, the oceans, and the ice. And since you are a professor of geography at the University of Winnipeg from 1988 to 1996, please tell us about the influence of the oceans over climate and what is Gulf Stream and its role.
Okay, the oceans are an enormous factor. In fact, water in general is the most important element on the Earth. I want to change the name of the planet from Earth to water, right? And one of the things that you notice, and this shows you the scientific, almost rigid thinking, because when they go to other places, NASA goes to Mars, what are they looking for? Water. Why? Because they assume that water is essential to life. Well, it's essential to life on Earth, but that doesn't mean that it's essential to life on other planets. It's the same thing as they used to say, without sunlight, you cannot have life. They then go to the bottom of the ocean, and here's heat vents putting out heat, and there's plant life and animal life growing there under incredible conditions with absolutely no sunlight at all. So one of the things that we have to do as science, which is what's so important about what you're doing in your program, is you have to keep a very open mind as a scientist. You cannot reject anything. All you can do, and this is what I used to tell my students, I'm going to tell you the truth for today. It wasn't the truth yesterday, and it won't be the truth tomorrow, because science is constantly changing, constantly learning and taking different views.
Yes, but please talk about Gulf Stream.
Yes, okay, I'll get to that. So the oceans cover 70% of the surface of the Earth. They the way that they absorb energy from the sun and give off heat is very different than the land. All right, and so water is first of all, the sunlight can penetrate quite deep into the water, down 30 or 40 meters into the water, and then it gets pitch black. So you've got the sunlight is heating a very large portion of the surface of the ocean. The land, the sun doesn't penetrate at all, or hardly at all. And I used to tease my students, and I say, no, we're going to do an experiment where we're going to have some worms under the ground, and we're going to dig them up suddenly and pull them out, and you'll see them blinking because the sunlight is affecting their eyes. So the surface of the Earth, the soil, only a very, very few millimeters is actually heated by the sunlight. And even on a beach in this hot summer, you don't have to dig down very far, and it's quite cool. And of course, people throughout history have used that difference of heating and cooling of water and land. So people will dig down to store their food in the summertime. Probably do that in Romania historically. In North America, we call them root cellars. Well, the different heating of the water and the land, so the oceans take longer to warm up, but slower to cool down. The land heats up very quickly and cools down very quickly. Now, you experience that in Romania. That difference of the rate of heating of water and the rate of heating of land creates what we call continentalism. Continentalism is the distance that you are from an ocean. So what the ocean does is it lowers the maximum temperature, but also raises the minimum temperature. So the range of temperature is quite narrow. If you look at Britain, for example, the temperature range, because it's modified by the ocean, is like this. If you get into Romania, it's this, because the land heats up more quickly and cools down more quickly. And when you see the extreme of this, if you go to Verkhoyansk or Omsk in Siberia, the temperature range there is the widest anywhere on the planet, even wider than the South Pole, so that you can get, minus 50, minus 55 in the winter, plus 30, plus 40 in the summer. So the temperature range is this wide. In Canada, you see the difference that in Winnipeg, in the center of Canada, the temperature range is about, it's minus 40 to minus 40, or plus 40, I should say, about 80-degree temperature range. On the East Coast, because of the ocean, it's about a 40-degree temperature range. On the West Coast, it's even less because you've got warm ocean currents coming onshore. Now, in the Atlantic Ocean, the circulation caused by those wind patterns that we talked about earlier, so the winds are blowing across at the equator, warms the water up into the Gulf of Mexico off Florida, water temperatures getting up to 27, 28 degrees Celsius. And of course, that then is carried north because of the shape of the land and the wind patterns. It's picked up off the coast of eastern North America by the jet stream winds that then carry it as the Gulf Stream, carrying all of that tropical heat up and warming the western part of North America. And so that Gulf Stream is very, very important in terms of the whole weather and climate patterns of Europe. The influence of it moving inland, by the time you get to Germany, the effect of the Gulf Stream is basically gone. It does have an effect in the north, around northern Norway and the Kola Peninsula in Russia. And of course, that's where you get Murmansk, which is at 70 degrees latitude. That is, it's north of the Arctic Circle, yet it's ice-free year-round because of the warm water being carried up there, okay? But as I said, you don't go very far inland. As far as Germany, the effects of the Gulf Stream is no longer there. And certainly in terms of its impact on Romania, it's virtually minimal. Romania's weather is controlled by the rapid heating and cooling of the land, summer to winter, and then the effects of the jet stream and the wind patterns that bring in warm air or cold air. Those are the controlling factors in Romania. So the oceans, in terms of their ability to store heat and moderate temperatures, is very, very important. Now, you can apply that, by the way, and I talk about calling the planet water. We talk about greenhouse gases. Everybody talks about CO2, but it's only 4% of the greenhouse gases. Water vapor, which is water as a gas, is 95% of the greenhouse gases, and it is what controls the temperature in the atmosphere. So the farmers in Romania would know that in the fall, if you've got a cloud cover, the temperature won't drop much overnight. But if the sky is clear, there's no water vapor, the heat escapes and the temperature drops very dramatically. So the water vapor in the atmosphere is a major control of the temperature. And you see that in the deserts. The CO2, it doesn't matter what it does, but the water vapor is not there either. You got like 19% humidity in the Sahara Desert. So the desert heats up very hot during the day and cools down very rapidly at night. So for example, a place in southern Algeria, a place called Insula, they recorded 52.6 degrees Celsius daytime high. By noon, by midnight, it was minus 3.6 Celsius. So a 55 degrees Celsius temperature range in a 24-hour period. Why? Because there's no water vapor to modify the temperature range. Right. And so, of course, you see that on a daily basis in Romania.
Dear Professor Timbal, please let's meet for part 2 of our interview on our next program, and thank you very much.
Okay, thank you, Christian. Have a good summer.
Data viitoare la Știință și Cunoaștere, în partea a doua a interviului cu profesorul Timbal din Canada, vom vorbi despre influența solurilor și a elementelor topografice asupra climei, rolul circulației curenților atmosferici, rolul norilor în reglarea termică, iar spre final veți afla adevăratele cauze ale intensificării nivelurilor de radiații cosmice și solare care ajung la altitudini din ce în ce mai joase. Fiți alături de noi data viitoare la o nouă întâlnire cu Știință și Cunoaștere.